Another new graphical characteristic of a rational function is what happens in what we famously called for polynomials the end behavior. Now remember, for polynomials the end behavior, right, for a poly, the end behavior in either direction, it was unbounded, right? So depending on the degree of the polynomial and the leading coefficient, eventually the polynomial would go out to infinity. So it was unbounded situations. But when we take a polynomial divided by a polynomial, it turns out that that might not always be the case in the end behavior. So what could happen, right, is as our inputs get large, both positively or negatively, the inputs are two things that can happen, or the outputs, excuse me. One possibility, and this is most likely the case, is that we get a horizontal asymptote. And so by definition, what a horizontal asymptote is, it's actually a horizontal line, we'll call it y equals L, where the graph approaches this line as our inputs get large. So mathematically speaking, we're talking about x going to positive infinity, so getting large positively, or x going to negative infinity, getting large negatively. And then what's happening is the outputs of the function, r of x, approach some L. So, and again, graphically speaking here, if I have, there's my x-axis and my y-axis, and let's just say this is the line y equals L. What we're saying is as x goes to positive infinity, as we get big in this direction, the graph is starting to, the output values get closer and closer to this L. Whether it's on the top or the bottom's a different story. We'll have to figure out that. But I do know that the graph is basically tapering off, if you would, getting closer and closer to that line. And same thing happening in this direction, right? As my x's go to negative infinity in that direction, the graph is either going to taper down or taper up to that horizontal line. So that's essentially what that visualization is, what this graph is basically saying. Okay? Oblique asymptotes, what's happening here, these are a little bit harder to see, but what's happening is the function, right, starts behaving. Let me try to draw a picture of something that would have an oblique asymptote. Would start behaving something like this. And so there's some line, right, that the function, it's not a horizontal line, but it might be a slant, right, or it could even be a parabola or a cubic graph, but the function starts to behave very much like that line, or very much like there's somewhere the graph actually hugs along some parabolic shape that we have. So that's why we call it oblique. Most of the times they're what we call slant asymptotes because they're basically a line. Again, we're talking about the end behavior. As x goes to positive infinity or negative infinity, the graph eventually starts behaving just like that line. Alrighty, and we'll investigate this more obviously and find them in a bit. But what I will tell you at this moment is graphically, unlike the vertical asymptotes, it is actually okay to cross a horizontal oblique asymptote because we're not talking about anything being undefined here. We're basically talking about the end behavior. So the function can probably do all kinds of crazy things, right? It can cross the horizontal asymptote. It might even cross the slant asymptote several times. But since we're talking about the end behavior, that's basically what has to happen towards the end. The graph has to start behaving like a horizontal line, where it starts to have to behave like some other function, a linear or quadratic or whatever the case might be. So that is another different aspect about the end behavior of an asymptote. You can possibly, as x is in between negative and positive infinity, you might actually cross the horizontal asymptote several times. You might not, all right? But we're not. It's not like a vertical asymptote where there's an undefinition going on, and there's no way to do that. All right. So there's our new topic. Obviously, what we're going to do is we're going to turn to technology in a moment and kind of do some investigation and try to figure out, best practices in terms of finding the end behavior. But let me go ahead, since I'm 5 minutes into this, we'll do that investigation in another video coming soon.